Wow, good morning, everybody. You know, when they told me that we were going to be speaking in this venue, I was sure they were wrong. Thank you very much for showing up. I was expecting a very small room. My name is Derek Adam, and with a name like Adam, you might assume that I'm a #1 guy, and I will be talking first. But let me also introduce my friend here, Ryan Puffer. And despite his name, he's not just blowing air at you. He knows a lot. He's big in security. Ryan, say something so they know your mic works.
Hello. Good morning. It's our exciting day. We got our great celebration this evening, and we're happy you're here talking to us about security. So let's get started. Why are you here? You must love security.
Here because I love security. Do you love security?
I love security too.
Fantastic.
Who loves security?
You do too. Oh, come on.
Not as many hands as I expected.
Did you guys not get your Starbucks this morning? Okay, well, we're going to give you some practical advice today about the most impactful things that you can do to increase the security of your Windows server. And, why don't you take line 3?
We're going to make sure we show you how, when you combine Windows Server with the power of the Microsoft Cloud, you can get a much better, more easy to deploy, and more secure experience. So, let's talk about some of the amazing things we've been doing in the last 10 years.
What have they done for us lately?
Wow. So who's running Windows Server 2012 or later? All right. Drop your hands if you're going to 2016 only or later. Oh, we got a few. All right. Who's on 2019 only?
Wow. Right. Respect.
2008 R2. All right. We're here to convince you otherwise. 2012, amazing year, a lot of great security investments. Big one, BitLocker support for failover clustering and support for BitLocker Network Unlock, which Derek's going to demo today for you to show you really how cool it is that you can lock a server into your physical data center. We also introduced group managed service accounts, which was one of our first attempts at trying to simplify and improve the security of how you do service accounts for your applications. So you're hosting a site in IIS. You probably today are putting in a username and a password that never gets changed. Someone has it documented on a notepad. Group managed service accounts are out there to solve that problem by automatically rotating that password and managing it all for you behind the scenes. So that was an amazing innovation in 2012, but we didn't stop there. We moved on to add Secure Boot as well. That had been around in Windows 8 for client as well. We wanted to bring the same great technology to server to prove that when you turn on this computer, we can evaluate all the binaries being loaded and say this is a cryptographically signed, Microsoft-produced bootloader, and that you have not introduced any bootkits or rootkits into the boot process. So let's talk about 2016.
Yeah, 2012 is so last decade.
I know. So 2016 was a huge year for Windows Server security. We started with things like Control Flow Guard, which is a kernel mechanism to go and say when you compile your app, you can give hints to Windows and say, my app should execute in this order. And if it's not executing in this order, something has attacked my app, and you should stop that. So that's an amazingly powerful technology for application developers building on Windows Server. We also introduced Credential Guard and Remote Credential Guard. These are technologies to protect your identity when you're signing into network services and make sure that if someone does get admin access with malware like Mimikatz on your server, you can't go scrape the memory and go find those credentials and reuse them across the enterprise. We also introduced Hypervisor Enforced Code Integrity. So kind of like how Secure Boot is protecting the bootloader, Hypervisor Enforced Code Integrity is using a mechanism to protect the kernel technology for application developers building on Windows Server. We also introduced Credential Guard and Remote Credential Guard. These are technologies to protect your identity when you're signing into network services and make sure that if someone does get admin access with malware like Mimikatz on your server, you can't go scrape the memory and go find those credentials and reuse them across the enterprise. We also introduced Hypervisor Enforced Code Integrity. So kind of like how Secure Boot is protecting the bootloader, Hypervisor Enforced Code Integrity is using a mechanism to protect the kernel code to make sure that everything running in the Windows kernel is authentic and intentional. Nothing else can go load into memory and execute with kernel permissions. Hyper-V shielded VMs. Who's heard of those before? Who watched me talk about them before? Oh, shame. All right. Well, those are my baby, and I'm very happy to get people using them. This is our encrypted VM technology solution. Very powerful in Windows Server 2016. You can start with an encrypted template, keep that VM encrypted all the way throughout its life, and you're using keys that the VM owner is in control of. It's not the platform who can go inspect those. PowerShell, just enough administration, so bringing role-based access control to your management plane in PowerShell. And then Windows Defender. So we've had Windows Defender around for many years. It started out as an anti-spyware tool. In Windows Server 2016, we put it in box as an antivirus solution to help protect you for free. And Windows Defender Application Control is a user mode code integrity policy where you can say, my application server should only ever run these 5 things. Let's make sure that it only ever runs those 5 things. We didn't stop there either. Windows Server 2019, we keep innovating. And so in Windows Server 2019, we added advanced threat protection built in box. ATP is available down level as well, but in 2019, you just got to configure it. It's already there for you with advanced sensors to give you the best threat intelligence. Additionally, we introduced software-defined networking encrypted subnets. So if you are building your hyperconverged infrastructure and you're having your VMs talk to each other, you can make sure that communication between your Hyper-V hosts is encrypted.
Hey, we should talk about how we're going to hand off. I mean, we've got all this content. And
I know. Wow. How are we going to get through it all?
So how about I'll start with the secure hardware and encrypting data, and then you should take the virtualization stuff and managing systems. And you know what? Why don't you take the next one, too?
That sounds good.
Got continuity, and then I'll talk about Sentinel at the end.
Perfect.
OK, give me that.
All right.
All right, cool. So these are the things we're going to show you today. A lot of this is low-hanging fruit. Let's just start with hardware. Hardware in a secure cloud. Hardware selection is actually terribly, terribly important. And these are the new basics. You should have UEFI firmware. A shocking number of servers out there are still on BIOS. Amazing. TPM, I say 2.0. Even a TPM 1.2 would be better. And Secure Boot, which is a feature of UEFI that actually ensures that you're booting with integrity, the kind of code that you want. So the question to you is, does your ancient hardware have any of this? Just hands up if you think you've got all 3 of these. OK, so some people, but most of you don't. And that's actually one of the biggest challenges we have. So when you go home and you're thinking about what that purchase order is for your next server, this needs to be on the list. And I'll actually talk about how you would look this stuff up and find the right hardware. Because the sad truth is, a lot of the features that we're talking about today, they're rooted in the hardware. Right? The OS who's using this hardware feature to protect you can't protect you if the hardware's not present. And then there's some configuration basics. I'm just saying this for completeness. I'm sure that all of you do this. But you should update your firmware and microcode. Windows Update did actually update the microcode for a number of attacks that came out last year around December, things like Spectre and Meltdown and other attacks on TPM hardware to ensure that none of those sorts of things can affect you. But in addition, you might need to update your firmware. And for that, usually you're going to have to go back to your OEM. So make sure that you're actually making those checks and adding that stuff back. You also should lock down your baseboard management controller. You know, lots of vendors have different names for this. I think Dell calls it iDRAC, and there's another one that's called ILO for integrated lights out management. It's all the same thing. This is basically having console-level access with a username and password that's set at the manufacturer, and then you are supposed to update it. If you haven't, you're giving root-level access even earlier than the operating system to someone. So go ahead and change that, and turn off any protocols that you don't really need. Together, this helps form a hardware root of trust for your server hardware. Let's start with a TPM. This is a security coprocessor. It measures the integrity of your system. So if you have a boot application coming up, we want to know that the next time it's the same one. This is how BitLocker knows that this is booting with integrity. If that's not a boot application that happened last time, I'm not going to release the keys that will unlock your drives. And that's how you get both integrity and protection for your data. Then there's also Secure Boot. Secure Boot is a UEFI feature that goes and checks to see if the database in the firmware has a code signing certificate for the bootloader that's coming up. And if it doesn't, it says, hey, I don't trust that code. This is how you can prevent rootkits from taking hold of your system invisibly. And lastly, we have, of course, virtualization. Virtualization is not just for VMs. It's a wonderful isolation technology as well. And this is how you can have a secure kernel separate from the rest of the kernel. A kernel-level exploit, then, can't go and get things like credentials. And this is something that Ryan's going to talk about later with Credential Guard. So I have a stage that's for visionaries. I have one vision slide. And this is where I believe that modern security for hardware of servers should go. I've talked about this as level 1. The truth is today, this is not your level 1 security. When you order a server, you won't necessarily get all these things, but you should. We call this VBS capable, virtualization-based security capable. That just means it's capable. The next level would be to actually turn it on. In the future, I'd like to make it so these things are automatically turned on. We're not there yet. That's what this talk is about. We're going to show you how to turn on a lot of these features. And then level 3, this is very much thinking in the future. We want to add things that enable dynamic attestation for the health of your server. Wouldn't it be great if you knew that this is running the code that I expect it to, none of the configuration that I expect has changed? And maybe you could even use this for something like a conditional access story for your server. And like I said, this is visionary. I'm working with partners now on hardware that might actually do this, people like Dell and Fujitsu and HP and many others. And I'm hoping that by next time we meet at Ignite 2020, we'll be able to announce something. Fingers crossed. We call that System Guard. So I said that it might be hard for you to find this hardware. You just go to the server catalog and look for hardware assurance. That's how you can get that level 1 security that I was talking about just a minute ago. So I've talked about the kind of hardware that will be on your premises. But what about the security of the hardware in the cloud? What does Azure do? In an Azure data center, we manage and protect the hardware for you. We secure the hardware, of course, and attest to it. I'll talk about that in just a moment. And we also, of course, do background checks and have physical security for all of our data centers. It's kind of a given. But we also have this minimal OS, engineered for performance and security. We also have something that probably you don't have, and that is close partnerships directly with the chip manufacturers and with the security community itself. So we can hear about vulnerabilities long before they're actually released to the public and have patches ready to go before you even hear about them. And I'd like to say that we are actually taking a leadership role in this. So you might be familiar with a thing called Project Odyssey. Within that, it's in the Open Computing project. And we have another project in there called Project Cerberus. This is about defining a NIST 800-193 secure hardware for your servers. And it's not just anyone's servers. Because we've opened this, we're doing this as an open project, this will benefit any cloud. And our cloud is already running with this. So you have attestation that the firmware is good in order to boot even the fabric. The heartbeat of our company is security. You're probably not surprised to hear that Microsoft is under attack pretty much constantly. We learn a lot from that. The Cyber Defense Operations Center is kind of the beating heart of our security. Protect, detect, respond. Protect, detect, respond. All right, enough of the sales pitchy stuff. I want to actually show you something about encrypting your data. BitLocker is our technology for this. The BitLocker basics, I think most of you know. If any of you have a laptop these days that has the shiny Windows logo or the Microsoft logo on the back, a Surface anything, you're using device encryption. And it's the full volume encryption that comes with Windows. Why do you want that? Well, of course, you want privacy for your data, and you want boot integrity. It's available on Windows, of course. It's available on Windows Server as well, and it's also on your Azure Windows VMs. To enable it on a server, you add the optional component, as you would for any feature. And in Azure, you enable it through the Azure Disk Encryption. You can manage this in a number of ways. You can use group policy to set the activation rules for your BitLocker policy. You can activate it with PowerShell and give every little twiddle that you want. We also support it through SCCM. There are some default policies that I get a lot of questions about, so I'm just going to get in front of that. I get asked, is XTS 128 good enough? The answer is, for most people, yes. That's why it's the default. I mean, is the death of our solar system long enough to wait for classical computing to break this algorithm? I think so. That's probably good enough. But we know about this thing called quantum computing. It was even in the keynote. And there's a thing called Grover's algorithm that can cut the key space in half. Not just 1 bit, half the bits, if we had a quantum computer. We don't have a practical quantum computer yet, but if you're thinking about things in terms of years, or if you're working with an organization that's extremely worried about this, say one of the government agencies, you might want to go with 256 in order to get 128-bit protection even in a quantum world. You might want to offload the encryption to a self-encrypting drive. Okay, that will get you some performance. I just want to give a word of caution about that, because there were some known vulnerabilities that were discovered earlier this year in the firmware of certain self-encrypting drives. Not all of them, but enough to make us concerned. When you're sourcing your drives, you need to know from your manufacturer, have they taken care of that vulnerability? And we no longer do hardware encryption offload with BitLocker by default. We used to. The other thing is, just from a practical perspective, when you're buying a system and you want it to be using the said encryption to boot, the firmware needs to be able to do that. It needs to know that it's there. So if you're buying that drive separate from the system, chances are your system firmware isn't supporting it. So just get a system with the SED in it as a logoed system, and that'll take care of it for you. Some obvious best practices. Well, back up your recovery keys. You don't want to lose your data. Rotate them if there's a risk of exposure. Perhaps maybe you have an employee event where one of your admins needs to leave. Go ahead and rotate those server keys. And the good news is that this week we announced that Microsoft Endpoint Encryption, or Endpoint Manager, is now available and doing this key rotation. If any of you are familiar with the Microsoft BitLocker Administration and Management Pack, that logic just got rolled into SCCM and rebranded as Endpoint Manager with all of the goodness of Intune. I'm not going to go into the details of that because there are whole sessions about that. You can take a snap of this so you can go and look that up. Now I'm going to talk about a feature that's been there for a while, but you may not even know about. What is it? Well, Network Unlock gives you a seamless boot experience, but only on your network. You might want to have a second factor before you enable that encryption. You might want to make sure that you have something you have or something you know before it actually boots to give higher physical security. It's available for your on-prem servers that have a TPM. Again, I'm coming back to you. You need to have the right hardware. And only on your wired network. So how would you enable this? We use Windows deployment services to release the key, so you need to enable that feature on WDS. Create a certificate, put it on your WDS server, and update your group policy to go tell those clients, including your servers, that they should go and make network unlock protectors. And to get that second factor all of the time, you would turn on TPM plus PIN. Let me show you how that looks. So I have a couple of VMs here. I've got an encrypted server, and you can see here it's using a PIN. And I have a Windows deployment server. It's using, I'm just going to use the debug log so you can see the events as they come in as I'm doing this. So what happens when I restart this? You'd think that when I'm restarting it, and because it has a TPM plus PIN protector, that I would be prompted. But here it is, juggling the dots away, and in a moment, it just booted. Wow. I can just log in. My workloads that would automatically come up on boot will be already there. great shape. And on the Windows deployment server, what was going on there while that was happening? Well, you can see I had a network key protector request. It was processed. Hold on, let me highlight that. OK, the NKP request was processed successfully. And it came over IPv6. OK, great. I should probably prove to you that this is actually TPM plus PIN. OK. So what would the experience be for your attacker? If I shut down this WDS server that's serving up these keys over the network, this would be the kind of experience that someone who walked away with your server would have. OK, I'm going to make sure the WDS server is off, and then we'll just restart the encrypted server. And this is going to take a few seconds more. Reason for that is it's trying to reach the network. It's trying to find a WDS server that can unlock it, and it's not. So there you go. Let me just switch over here. OK. OK. So that's how that works. Probably you're wondering, how did I do that? So let me walk through what the flow was in the background. So we'll start off with our test server. Let's say it was a database. It's encrypted and it's off. It has a local TPM configured with a network unlock protector that was created when it was already booted. And then when it powers on, it retrieves a couple of keys. One, it checks that the integrity is good with a TPM-based protector. And then it also looks to see if it has a key from the network, from our Windows deployment services. And you're getting this key over bootp. It's basically a DHCP protocol vendor extension. And it knows to listen to this when it's set up in WDS. If WDS has the matching private key, it'll decrypt that protector and send it back. It's wrapped with a session key that came in the original package that went to the WDS server. If everything goes well, your TPM protector and the WDS key that came over the network will be combined cryptographically to make the key that actually unlocks your server. And now you can boot. I got one whistle, thanks. I didn't plant him, thank you. All right, what about BitLocker in Azure? So Azure Disk Encryption, if you've ever turned this on for your VMs, is just using BitLocker. The keys are protected in the Azure Key Vault, which is a hardware security module, so that only your tenant can boot that VM or see it at all. So it protects your data at rest, your local caches, and data in transit in the sense that when the VM is transferred from encrypted storage to the host, it stays encrypted. So let me just do a quick walkthrough. So you start off, you got your Azure portal, you create a resource. If you already have a key vault, you can skip this step. But making a key vault, you just type it in, create it. If this is the first time you've ever created something in Azure, I suppose you might need to make a resource group. You can use the one that you've already got and give the vault a simple name. And then you can add this feature, Azure Disk Encryption for volume encryption. So once you have your key vault, now you can use it with your VMs. In the quick start version, I'll just use 2016. There's now 2019 versions in Azure. You go ahead and create your VM, and then in the disk section, you choose encryption. Once you do that, it'll ask you what key vault to use. Bob's your uncle. So I've talked an awfully long time. Maybe it's your turn.
Sounds good. Let's talk about some of the virtualization-based security stuff Derek mentioned earlier. Who's heard of VBS? A couple people? OK. VBS was a huge innovation and re-architecture of Windows in the Windows Server 2016 and Windows 10 1607 timeframe. And its idea is to protect Windows from admin and kernel attacks. So when you look at Windows, if you just imagine your physical server here, you've got Windows OS running on physical hardware. It's a little more nuanced than that. So if we split Windows out into its component parts, there's a kernel, which runs all of the NT kernel and drivers and all the stuff that keeps your system running and manages access to resources. And then there's user mode, where your apps and services are running. Now, the kernel mode is more privileged than user mode. So the kernel mode gets to enforce protections and restrictions on user mode. That's how, for example, we say there's a security boundary between user mode and kernel mode. Your app should not be able to break into the NT kernel. The problem is, what happens if you're admin and you get access to the kernel? You install some malware. What's going to protect itself if the enforcement engine is in the kernel? You could just overwrite that, have that be skipped. So we introduced this concept of virtualization-based security, where we have an even higher level of privilege than your main OS kernel. And we do that by implementing a secure kernel. It's a very minimal kernel, and we run it in a dedicated, self-managed tiny VM. So when you start up your computer, we load the hypervisor, we load secure kernel, and then we load your regular kernel. And we introduced this concept of a virtual trust level, because typically the root partition in Hyper-V, which is the main OS that you log into, has control over the other VMs on that machine. Now in this case, we have the reverse. We're saying secure kernel is controlling the main kernel and protecting things in itself from the main kernel. So VTLs are a special memory setting in the hypervisor that say, look, the main kernel should never be allowed to talk to the secure kernel. And that gives us the platform on which we can build some really awesome security technology. So a couple features that use this are hypervisor enforced code integrity. I mentioned that earlier. Windows ships with a default code integrity policy. We make sure that the kernel code is signed by Microsoft. When the bootloader finishes loading, it makes sure that it's loading authentic Windows. However, what happens if the enforcement engine is compromised? That's where hypervisor enforced code integrity comes in. We can enforce it from a different VM, which has introspection capabilities into the regular one and say, look, that memory can't be marked as executable because it's not trusted. Credential Guard is the concept of taking secrets from the main OS and hiding them. When you log in your server, you get a Kerberos ticket granting ticket. It just stores in memory. What if we put that over in VBS? That way, you get the protection of the hardware features that power virtualization today and keep one VM from talking to another to stop any attacks and malware in your OS from breaching those credentials and reusing them. Shielded VMs I mentioned earlier. Shielded VMs get virtual TPMs. Normally, your TPM is your physical root of trust. So in a virtual one, we want to make sure the virtual TPM is in a safe place. So we put that in VBS. And lastly, announced this week at Ignite, is SQL Server always encrypted with secure enclaves. So there's now a feature in SQL Server where you can have encrypted columns in your table, and you want to run an encrypted query on it using a key owned and kept on the client. We use the concept of a software enclave that runs in VBS, and all of the query and execution happens in VBS. So anyone who's looking at the memory of SQL Server on the host would have no idea what query was run, what the results were. Definitely take a look at those sessions if that's interesting to you. So let's walk through what it's like to enable VBS. So if you're on your server, the easiest way to deploy it is with group policy. So I'm just going to open up GPEdit over here, going into computer configuration, admin templates, system, and then device guard. Here you'll find turn on virtualization-based security. Obviously, we want to enable it. And then you're going to have a couple options here. The platform security level is very important. This is the minimum level of hardware features needed to run VBS. Secure boot's always a requirement, but you can also say, I need an IOMMU so that a direct memory access device like a NIC cannot go and access the memory of VBS. Once you set that, you can choose which features to enable. Here we're going to enable virtualization-based protection of code integrity and credential guard. Now the lock here is a setting where once you've tested it and you know it's working well, you can lock the requirement to run this into a UEFI secure boot variable. Once it's there, if anyone tries to disable it, your system will choose to not boot rather than boot insecurely. And so now we've rebooted. You can go into MS-Info32 and see that VBS is running. It'll show you what platform security features you have and which VBS features you've enabled. The one thing that we often hear is, that's awesome, I can protect my physical machines. What about my virtual ones? And this is kind of an overlooked area. It's actually been supported since 2016. And the important thing is you want to remember, for Hyper-V Gen 2 VMs, it's there by default. So it's an opt-out for Gen 2 VMs, and it's actually extra, you get extra performance boost in that we don't require you to have a nested hypervisor. We will allow Gen 2 VMs to ask the host, hey, can you give me a VBS partition? Host will comply, and you get a very minimal performance impact. For Hyper-V Gen 1, third-party VMs, and Gen 2, if you've enabled nested virtualization and are using Hyper-V in that VM, you can still use VBS, but you're going to have the performance impact of double virtualization. So here's a quick table kind of summarizing what we have there. All right, so let's move on and talk a little bit about managing your systems. It's very important to manage your systems remotely and securely. Nowadays, it's pretty uncommon to manage a system in person, but when we manage remotely, there's a lot of different tools you can use to make it better. So the first one I want to talk about is remote desktop. We all have to sign into a server every once in a while and actually use the GUI and take a look at something that failed or investigate some kind of other issue going on the server. And when you log into a server, typically your credential is being sent over to the server, so that way you can go authenticate to other resources once you've connected. But when you disconnect remote desktop, they're left there. They sit in memory for a little bit. So if someone else were to get onto that server and go inspect the memory, they could theoretically get access to those. So I want to talk a little bit about Remote Credential Guard. This is a great feature. All you have to do is enable restricted admin mode for RDP on the target server and add this remote guard flag to your invocation of the remote desktop client. When you use Remote Credential Guard, we don't send the whole credential over. We send an encrypted version of it. So that every time that remote server tries to use your identity, it has to go back over remote desktop and say, hey, can you get me a new service ticket so that I can go talk to another network resource? So this time, when you disconnect your remote desktop connection, that server, and if you reached out to other resources, including, imagine, a nested RDP session, those will all immediately be disconnected and can no longer use your credentials. Really powerful feature, and surprisingly, makes it easier because it's now single sign-on. Remote Guard only uses your current logged in identity, so when you use that, it's quick and easy access to remote desktop. How many of you have been to the Windows Admin Center sessions? There's some awesome stuff this week going on with Windows Admin Center. I use Windows Admin Center almost every day to manage my servers. There's a lot of great features and configuration options that you should consider when you're setting up Windows Admin Center. The first one, try to use Kerberos constrained delegation. The Windows Admin Center gateway has to be able to reach out to all the servers you're managing. You can use unconstrained delegation to say, well, it should be able to access all my servers. I don't care who it talks to. We've been talking about how bad unconstrained delegation is for years now because it makes it very easy to replicate and move around your network. So definitely try to use Kerberos constrained delegation. They have great docs on how to set it up on their website. The second one, enable PowerShell module logging. So PowerShell has awesome logging and transcription features. We highly encourage you to go and use those so that everything someone does through Windows Admin Center is put into the event log and can be sent to your security event system. Lastly, deploy role-based access control. So to enable PowerShell script block logging, this applies to the whole server, regardless of whether you're using Windows Admin Center or you're managing directly through PowerShell. Configure that through group policy. You can also do transcription if you want to get like a visual representation of everything someone ran in their PowerShell session together as a text file. And for role-based access control, if you go into the settings of a server once you've logged in with Windows Admin Center, go to the remote role-based access control setting, click apply, it will deploy just enough administration PowerShell configuration and give you 3 default roles: administrators, Hyper-V admins, and readers. We'd love to hear your feedback on this, so definitely reach out to us based on your experience with role-based access control. So role-based access control, I mentioned it's using GIA. How that works, you are an unprivileged user. You do not have admin rights on the target server. When you connect, GIA is a PowerShell endpoint that has a mapping, and it says, Ryan can go do these special commands, so he's only a Hyper-V admin. He can change things on Hyper-V, he can read any other setting, but he can't go like reboot the server. And then it uses a temporary local admin account to execute those allowed commands on my behalf. So let's talk a little bit about antivirus now. I mentioned earlier, Defender Antivirus comes with your license to Windows Server. It's in box with Windows Server 2016. It's getting amazing scores in the AV tests for detection and performance and reliability. And it has pre-configured exclusions for server roles. Install Hyper-V, we'll make sure we don't scan your VHDXs and cause performance issues. Updates come through Windows Update. Make sure if you're using WSUS that you get those updates approved quickly so your servers stay up to date. And there's also a new extension in Windows Admin Center. It's in preview. You have to go install it separately. But now you can go manage Windows Defender through there. You can see your latest scan details. And if there are any recent events, you can go to the protection history and drill down and set some settings about what to do if similar malware is found again. Now, ATP is the extension of Defender into the cloud. It gives you an enterprise-wide view of all the threats facing your Windows 10 clients, your Office 365 users, and your Windows servers now. So ATP extends this to an enterprise-wide view with all the data from your enterprise, as well as threat intelligence from Microsoft. And it puts it in one great portal for you to view. It's been available since 2008 R2 with the download, but it's in box on Windows Server 2019. We introduced exploit protection, which is a replacement for Emmet, the exploit protection and experience toolkit, in Windows Server 1803, Windows Server 2019 as well. And all this data, again, it goes all up into the same great portals and APIs that you can use to access any of your Microsoft security data, including sending all of the ATP data over to the new Azure Sentinel service. So ATP on Windows Server here, just kind of showing, you get views of kind of your threat history. It helps you kind of drill down into enterprise-wide events. And to talk a little bit more about Sentinel, I'm going to hand it back over to Derek, who will close us out.
All right, thanks. So I'm going to switch to actual demo mode. I'm being rather brave here. If you've experienced the network, it can be kind of exciting sometimes.
There we go.
Oh, wow, it actually worked. Yes. All right, so I'm just going to do a very quick walkthrough of this. So Azure Sentinel is this new service in Azure. And in the home of this screen, you do need to have Azure Log Analytics for this to work. I think I have a slide that talks a little bit about this, but I'm going to first walk through it. So here you can see a lot of events and alerts over time from a number of sources. How did I get that? Well, there are a crazy number of data connectors. Ryan just talked about advanced threat protection. It's got its own vertical integration for hunting, but you can also feed those signals into Azure Sentinel. But another thing that I want to draw your attention to is this handy-dandy thing, security events. And security events, with its very plain Jane name, is actually how you stream security events from your Windows servers connected to Azure Sentinel Workspace. And how can you use that? Well, in the logs, you can walk through and make your own queries in the Kusto language. So we were talking about that security event. What's under there? Well, all the richness that you'd expect, all these different data types that come in from security events. Well, let's say I want to make a query out of this. Okay, I'll just double click on it. Boom, there it is. Actually, I clicked too excitedly. I had too many of them. And then I want to see what kind of security events there are. Maybe I want to look at an event ID that I'm familiar with. Say it starts with, sounds like, I think 4625 is a login event. So you can see this IntelliSense experience is really slick. So as I'm going through this and I'm making up my different queries and whatnot, I might realize that this is pretty useful. I might want to say, hey, if there's any login attempts from some suspicious-looking machines, I should have some kind of event for that. And I can go and create alerts for these random queries that you make. There's also a bunch of pre-canned ones. And then you can just wait for these things to roll in. When you're making your different kinds of log events and whatnot, you can set the frequency for these things and the threshold. You might say, well, you know, if I get any of these events, I want to throw something. Or if your query said, oh, I only want to hear about it if they've tried 5 times or something like that. Kusta completely supports that. And then you can also avoid being spammed all day long by the same event or a repeated event from some attacker attacking a specific machine. But so you're getting all of the data that you need when you need it. So in this demo environment that I'm showing you right now, especially for Ignite, oh my gosh, I have 50 open incidents. Well, when you want to drill into those incidents, you just select it, and you can double-click and look into it. I believe we've got a, well, now you know this is how you know it's actually live. I can't see the investigation thing. So when you see these sorts of things, you can have alerts for them, but you can also go proactively hunting for them. And so we have this beautiful hunting experience with a bunch of different queries. And I'll let you go and explore those on your own time. And there's a handy link actually on the hunting site for how to get started hunting using Sentinel. So this is how you can turn your logs into insights. You have this data flowing in. Oh my goodness. Did you hide all those slides for me? I was going to click through all of them. That's fantastic.
No?
All right. So to get using Azure Sentinel, you just need to have Azure Log Analytics. That's how you gather all of that data in. And move forward, move forward.
Yeah, you went backwards.
I went backwards. OK, look. ATP.
Oh, still going backwards.
I'm so excited. I'm going backwards. Okay. Okay. So it's your security incident event management. It's also a SOAR, so that you can automate some of these things. You can take signals from all kinds of crazy sources, from the cloud and from on-prem, as you just saw. And you can enable those events for security from your Windows server. The next bazillion slides are actually my backup slides, because I actually did that live. There are a lot of resources for this, so I don't want to belabor the point. You can maybe take a snap of this. There is a threat hunting guide or a talk at 3 o'clock. It'll probably get pretty crowded, so you want to get there early. There's a workshop that actually does this. I bet by now it's full, but you never know. It is tomorrow morning, so maybe there'll be people who are tired after the party.
Awesome. Well, thanks so much for spending your time with us today. I hope you saw a little bit of some of the great innovation we've been doing with Windows Server, and especially how when you connect it to Azure services, we can help you make it even more secure. So we got a couple of links on the slide here. You'll get a copy with the deck as well. And we're almost out of time, but we can probably take one question, and then we'll be available afterwards for feedback in the hall.
Do we have a mic for our questions? No. All right. Go ahead.
So, VBS, right? So this kind of came up. So they're playing with their own Windows 10. So the credentials are stored in VBS, right? Stuff is still accessing the credentials. So how are you controlling what's accessing the controllers? Or I'm sorry, it's accessing the information in VBS to make sure that it's not compromised.
So this question was about how is it that you can actually have these credentials isolated from the kernel and still have them usable for authentication? Is that essentially the question?
If I want to make sure that what's accessing it, how are you making sure that what's accessing it, that it's not somehow compromised? That's great. It's in VBS, right? It's protected.
Oh, I see. So how do you know that the thing accessing the use of the credentials isn't compromised?
Yeah, I can take that. So the interface between VBS and the host is called a trustlet.
That's great. That's what I'm
Yes, and
Say it again?
it's called a trustlet. And it's trusted because only we can write them. Nobody else can put code that VBS will run. And it's a very narrow API. So we can't prevent your identity from being used like as an Oracle attack for malicious purposes. What we are preventing is someone from stealing the raw credential. So the ticket granting ticket stays there. And if someone needs to perform, get a service ticket, what's happening is we have a process on the host called LSA isolated. It goes and talks to VBS and says, hey, I know you have my TGT. Can you go help me make the request that I need to go send to the domain controller to go actually get this new service ticket? So the service tickets still stay in regular kernel memory, but something like Mimikatz traditionally work by scanning the memory for TGTs. And it's like, once I get this, I can just ask for unlimited service tickets, and especially not on that machine. So this is preventing you from stealing the TGT. Yeah.
All right, thanks.
Thanks.